Hello guys, my name is Saib and welcome to another episode of this 2D game programming with Canvas. And in the previous episode we've talked about physics, we've applied simple physics effects such as acceleration and friction, and we specified the speed of the acceleration and the drag of the friction, and we set up our own keyboard custom function, and we used that with the press and release. We configured these two for each key so that it does exactly like what we want. So if we look again into our implementation so far, you can see that, okay, but that's because of the gravity thing. So I have to pull my spaceship up so that I can actually control this one, because the gravity is gonna pull me down since it's just a downward force on this object, on the spaceship. So yeah, let me just comment the gravity for now, since we're not actually using it, it just stands in our way. So I'm just gonna control that one, comment that one out. And so far you can see that our spaceship moves freely around our canvas that way. So in this episode we just want to contain this spaceship into our canvas boundaries. So we're gonna come up with a function that actually does that. We've been doing this in the previous episodes. We've done that in the Bong game with the battles and even the ball. And we've done that in the keyboard episode, not the previous one, but I think the first version of the keyboard episode 1. And yeah, we're gonna make a custom function that works more more efficiently, and so we can use it with any value or any boundaries that we specify. We can specify a boundary for this, for instance, where I'm actually pointing at, or for a whole canvas. And we can simply do that by using the JavaScript sets. So before we actually talk about sets, let me just come up with a definition for this contain function. So I'm gonna call it contain, and this contain function is gonna take two things. The first one is the sprite, which in our case is the spaceship sprite. Sprite, as I said, in Bixi.js is just any 2D visual. It's not exactly the same as the sprites, the animation ones, the keyframe animation sprites. No, it's just any 2D visuals that we specify. In our case, it's just the spaceship in here. And the other thing is going to be the container, whether it's the canvas or whether it's any custom values that we specify. It can be anything. So before we actually specify this contain function, let's try to center our canvas to make it in the center. And this can be done easily by going up there and into our styling. And as I said, the render view is just a plain canvas tag. We can style it the same way by accessing. So I'm gonna call the render view that way, and I'm just gonna go style, and I can choose position. This is exactly like using in the style CSS and saying position. And for instance, I can just say relative or any other value such as absolute, for instance, which we'll be using in our case. So yeah, it's gonna be style position, and I'm gonna pass in the value of absolute like this, so that I can specify the top and the bottom down and everything, and the left and the right, and displacement of everything. So now I can just say render like this, and I can just say view, and I can say style, and I can just say top for now since I'm having the absolute position. And for the top I'm just gonna say 50%, which simply is gonna pull our canvas or a canvas element down by 50% from the top. So yeah, I hope that makes sense. And now it's gonna be for the top, and now we have the left, so that we actually go to the right by 50%, for instance. If you look at our canvas now, you can see that it's not centered exactly. Okay, I think we've done something that is not correct. So let's check a console like this, and we can go to the console. You can see that nothing actually is wrong. Okay, render view.style.position is going to be absolute. And now for maybe we just okay, nothing is different. Then what we're going to do is percent is actually after that. I don't know, this is a silly mistake. But look at that one. So now you can see that it got dragged to the bottom and to the right by 50%. But why exactly it's not centered is, that's very simple, because the left one, as left one in here, you can see that the left on top positions, the absolute ones, pushes our canvas, or our the canvas, or in our case is this stage, to that, for that direction, the bottom, and to the right one. So we have, if we want it to be centered vertically and horizontally, we have, all we need is to counter this by pulling that object up again. And this can be done simply by using the transform 3D, which works for any 3D, which is simply just a 3D vector, which represents the x and y and z. So now if you can just say under dot view dot style, and just say transform, and I can give it a value of transform 3D, translate 3D like this, and I have to pull that up again in the x and y so that it's exactly centered. 0 again, and finish like this. Now if I, okay, nothing happened. Okay, if you look at this one, translate, transform. Okay, we're making a lot of mistakes now. Now we can see that it's centered exactly where we want it to be, and I think this is much easier to deal with. Now we can just bounce everything. So yeah, let me command that one. So we specified an absolute positioning for it. We pushed down our canvas to the bottom and right, since I'm using the top and left one, by 50%, and then I has, since the positioning, or the top and left properties actually pushes our canvas down, so we have to center that one up, since it pushes them from the top left, it's not from the center. So by pushing up that one half the value, you're gonna see that it's exactly centered from the center, since it pushes from that one. So it goes down, we have to push that up. I hope that makes sense. And okay, this translate 3D is gonna be 0 for the Z, so we're actually dealing with 2D one. So I hope that makes sense. And okay, we can save now. There are many ways, so you can center your canvas, you can search it up, or you can use that one. So I'm just gonna command that one. I'm just gonna centering our canvas, which in our case is the stage or scene. So I'm gonna save now. And okay, back to our function, which is the contain one. What we're gonna do in here is simply we're gonna specify a set. Now if you're not familiar with the JavaScript sets, sets are exactly like an array. I think sets are a new thing that's been introduced in the latest version of JavaScript, the AS6, which is the latest version, I think. But it works exactly like an array, but one huge difference, and we can populate that with data, same as any arrays. But sets, the one huge difference is that it can only have one instance of each value. So if I'm having the left value for instance, or the right one, I can't have right or left. It just has one instant of each value. So let's try to do this so we can actually understand it more while implementing this one. So I'm just gonna say collision, and it's gonna be a new set object like this. So I'm having this collision set, and I'm having this sprite in this container. This sprite is gonna have its x and y, and this container is gonna have its x and y in width and height. So if I want to call this contain function, let's in the play, since this is the game's logic, I can just say let collision be equal to, and I can just say contain, like this. And this contain takes two things. First thing is the spaceship sprite, and the other thing will be an object which has an x, which is 0, and y is gonna be 0. So I want to cover our whole canvas. Then it's gonna be the width. We're gonna have the render width, view dot width, like this. And for the height is gonna be for the render dot view dot height, like this. So I hope that makes sense. We're gonna ask this spaceship sprite has its own x and y, and this is for the container, or what is the containment area that we want our spaceship to be contained in. And yeah, I hope that makes sense. And of course we're gonna return the collision at the end. But for now, let's specify the conditions where this spaceship has to be contained in. So the first thing we're going to specify, and you should know that for the sets we can actually use a lot of different properties, but I'm not going to explain JavaScript topics since this is out of the series scope. But you can see the sets has different things than array. For instance, we can get the size by calling the size. We can do for each to alter each value in our set. We can have push or add, sorry. We can have add in here, and all of the other things that a set has. I'm gonna leave a reference to sets so you can actually know more about them. But now you're gonna see why exactly I'll be using sets, so that we can have a certain value, and according to that value we're gonna have a certain action. And the 4 values that I'm gonna be using is the left and right and the top and down, since this is the collision, all of the possible collisions that we can have in our canvas. Okay, so the first thing, or the first condition, is gonna be for the left one. So I'm just gonna specify left, and I'm gonna say if the sprite dot x, which in our case is a spaceship that we've passed in here, if it's less than the container x dot x, that means that our spaceship went out of our canvas from the left side. So if it's, this is the top left of our spaceship, if it's lesser than the containers dot x, which is gonna be the 0 0, and it's gonna cover the whole, this is the containers x, and it's gonna cover the whole width and height like this. I hope that makes sense. And the y is also on the top left. So if this happens, then what I'm gonna do exactly is I'm just gonna say sprite dot x is gonna equal to the container dot x, so that it has the 0 position, so that it stops in here. I hope that makes sense. And of course, what I'm gonna do now is I'm gonna use my set and add a value which is the left one to represent a left collision. And I'm gonna refer to this case by calling the left, by checking if this collision has a left. So if it doesn't add a left, that means our spaceship didn't go to the left, and it didn't collide with the left side, or it didn't go back, it didn't go less than the 0 in here, which is the containers x that we specified. I hope that makes sense. It's really not that difficult. And now let's make another case for all of the other cases. Now for the top one, it's gonna be if sprite dot x. Now for the top one, it's gonna be a bit different. It's gonna be for the y. Now container, if it's less than container y, gonna do exactly the same. It's gonna be sprite. Let me just copy that one. It's gonna be y. It's gonna be equal to the container y, and I'm gonna add top in here like this. Now let's make it to the right. Now the right and different are gonna be a bit different because we have a width and height. Since our initial, or the starting point, is gonna be in the top left. So if I want it to be bigger than our canvas width, I have to add the width to it, so that the initial point plus the width represents our whole spaceship. So it's gonna be sprite.x plus our sprite.width, and it has to be bigger than our container width. We've done that in the bong and even in the keyboards episode, not the previous one, the custom function one. It's the first one. So we can bound our own object. So nothing is actually new in this series, but we only made a custom function that we can use even for any container area, not just our canvas. So yeah. So now I'm gonna make my sprite x. So I'm just gonna copy that one, and it's gonna have the value of the container width, which in our case is the 800, I think, yeah, 800, and I'm gonna minus the width, which is simply sprite width, so that it's exactly, so that it stops in here, yeah, like this. I hope that makes sense. Now you're gonna see it, okay, because I called the function up there, but it's not fully implemented yet. So yeah. And of course I'm gonna add a collision state for here that specifies that a right collision has occurred, like this, so I can refer to that. And now it's gonna be for the down one, same goes for the down, but the difference is gonna be plus the sprite height, and this should be bigger than the container height. And of course sprite.y now is gonna have the container height minus our sprite dot height, and I'm gonna add another collision here that specifies that you can just say left top and down or bottom collision, for instance, looks fine. Just say bottom down. Okay, it's better like this. And now in the case of no collision happens, let's just say that our spaceship is still in the center, we didn't move. So for that, what we're gonna do is we're gonna check the size. If the size is 0, that means no value has been inserted into our sets. Now you know, I think, why we're using a set, so that we can actually check the size of it. As I said, the set, we can use it, we can check the size by accessing the collision dot size like this. So if the size is 0, that means none of these cases actually happened. Nothing got added into our collision set, so it's gonna be no collision for now. So to do that, I'm just gonna say if, I'm just gonna go to my set, and I'm just gonna say size, and I'm gonna use the triple equal. We talked about this one, it just checks the type and also the value. You can use the double one, it doesn't really matter. And then it's gonna be 0, and if that happened, that means collision equals undefined, which means has no values, such that we just specified it like this with no value. And of course I'm gonna return my set, and now I can easily alter that one. So by calling the collision, we have our spaceship sprite, we have our containment. I want the container now to be our whole canvas, so I'm starting from the top left and I'm covering the width and height that's already been specified in here for the render review, that one, 800 by 600. Okay, so let's say now that I want, if my spaceship is, for instance, got into a bouncy area, for like this, for instance, I want it to bounce back. This is simply can be done if it's right and left. I'm just gonna inverse my axis velocity, the horizontal one, and if it's top and bottom, we're gonna just inverse the vertical velocity, the y one. This is really simple, we've done that a lot. So we're gonna do in here, I'm gonna say if there's a collision, so just on that one so we can finish. I'm just gonna say if collision, that means if there's a collision, and of course it's gonna be, since I'm actually colliding with it. And I'm just gonna put the conditions now. As I said, if it's right and left, it's gonna be, we're gonna inverse the x velocity. If it's top and bottom, we're gonna inverse the y. So yeah, so I'm just gonna say if collision. Now I'm gonna make my conditions if collision, and I'm just gonna use has to check if there's a value, and I'm just gonna say left, or if the collision set has a right, that mean a right and left, or this is an or, not an and. If a right and left collision happened, that means we're just gonna inverse the spaceship sprite dot velocity x is we're gonna inverse that simply by giving it a negative value, spaceship sprite dot velocity x, and it's gonna be minus, or we can multiply it by -1. It's fine. And also we're gonna do that for the top and bottom one. So I hope why we actually used a set now is clear to you, since I'm adding all of these values and I'm gonna check them using the has and what the sets in JavaScript offers me, such as the has and the size and all of these flexible things that are actually much modern than the using a single array. For instance, we can do that with an array. And the good thing about sets, as I said, is that we can only have one instance of any value, so I can't have two lefts, only one, which makes it more better for us. So now yeah, now for the y, I'm just gonna negative that one, and I think by now and everything in the x and y is gonna be altered by the velocity in here. So, and we have our acceleration and friction. So if I say it by now, you can see that I'm having the bouncy thing. So I'm just gonna go up, I'm gonna bounce down. For the top and bottom one, I can see the inverse of my y velocity, which of course just opposes my direction. If I go up, it's gonna go down again. Same goes for that one. I can go right and left. You can see that it bounces back. So even it goes into direction like this. If I go up and left, and yeah, I can go out, it's just bouncy things. This is actually a basic physics, but it makes like more of a real life simulation. Okay, I hope this makes sense, and we can release our graffiti now again, since this is actually gonna make it more look like this. And I'm just gonna say okay, now go down. You can see that bouncy now it goes down up. That's the I don't have to pull up because already reflects, but now we can see that it's got pulled down. I have to pull that one. Okay, that's everything for today's episode. I hope this was an informative episode, and I'll see you in the next episode.